Okay, is everyone able to see the slides on your end, Zach?
Yep, we got you.
Okay, great. Well, it's great to be on board today. I've had a long standing relationship with the folks there at Colorado State and the CoCoRaHS program. So it's good to come to you today and talk a little bit about drought. So you might be asking yourself, why this funny title? So I hope by the end of today I've answered why we have a clause of I before E except in the case of drought. And I think I'll lay that story out here as we go. So we get asked a lot of questions, just how dry is it? You've heard those jokes at the coffee shop or around your water cooler at work. And I noticed this year a lot, walking the dog around Lincoln, instead of my dogs going to the fire hydrants, the trees have been soliciting their business as well this year. That's how dry it's been around here in Lincoln. And I know for this part of the country, this has probably been a scene everywhere. But this next slide, I know a lot of you, obviously this is a CoCoRaHS oriented seminar series, so most of you are familiar with the standard 4-inch rain gauge that you see here on this post. But what you might not know is that Nolan and Henry are putting out rebates this year, I understand, to exchange these gauges for this new gauge, given the limited amount of precip we saw in 2012. So let's hope that 2013 is more favorable for us. At the end of today's talk, I'll give a little brief overview of the 2012 drought and a little glimpse into what the forecasts are showing for 2013 as we move forward rapidly into 2013. It seems like spring right on our doorstep here today. Just a little bit about the NDMC. Don't have enough time to go into great depth into all that we do, but we have been around since 1995. We're located at the University of Nebraska-Lincoln, and our main mission is to help people prepare for drought. And we try to do this in a more proactive risk management way versus a reactive crisis management paradigm, which I'll talk about in a little bit. So center was founded by Dr. Don Wilhite. Really, he's known as Dr. Drought. He's been doing drought his whole career, world renowned, and just a great start to the center was the presence of Dr. Wilhite. Dr. Hayes now is the current director, and we have a staff of around 16 folks. But what I see our main mission is doing is sort of serving as one of those boundary organizations that does translation of science to the public and science to policymakers. We do this through, we're a little unique as far as being in a university setting. We're not just a research group, but we develop decision support tools. We do a lot of research as well, but then we also have a strong outreach and extension program, working with our decision makers and stakeholders when we're developing these tools to get answers to their questions during development rather than develop it, drop it in their lap and say, here you go. We try to engage our customers from the very beginning, bring them through the entire process, and then develop that relationship and trust that I think it takes over time. So we have 3 program areas: the monitoring, which is more of our operational activities at the center. That's what I oversee. We also have a strong planning and social science that roots out of the background of Dr. Wilhite. And then we have a GI science, which you'll see some of the tools I'm talking about later on that deal with remote sensing, using satellites, for example, to assess conditions on the ground during times of drought and when times are good too. This map just shows you that the N in National Drought Mitigation Center definitely doesn't stand just for Nebraska. Our work is nationwide, our work is global, and these countries in red illustrate those countries we've worked with over the last several years and continue to do that moving forward. So a lot of that is with aid groups, various aid agencies, as well as the United Nations, and then several individual countries and their ministries around the world on drought, all things drought, I should say. So that leads us to what we'll talk about here today. What is drought? Well, I think it's easy to say that drought lies in the eye of the beholder. Everyone has a different definition of drought. There is no one universal definition of drought. So I hate to disappoint you if you thought you were getting the answer to that one today. The fact is that we all have different uses for water. We all have different needs for water. And it comes down at the end of the day, how do you use it? And once you are impacted, then you are in a drought. So that's the simplest way to define it, is when it impacts you. And you'll hear the theme come through on impacts throughout the entire talk. which will be a nice segue to the efforts that we've done and worked with a lot of you. I'm sure some of you on the webinar today have taken advantage of the interface in CoCoRaHS to actually enter in a drought impactor report that comes into our national database and the tool that we maintain here at the National Drought Mitigation Center. So flooding is a much different beast than our friend the zebra. It's a much more quick-hitting disaster. Same with hurricanes in general, same with earthquakes, flash floods, tornadoes, you name it. They're more like the cheetah, very quick, you don't see them coming. You do have the advantage, of course, with some technologies with radar that we can do a much better job than we used to be able to do with like tornadoes. And we can use satellites to certainly look at hurricanes a few days in advance as well. So that's where the contrast is between floods and drought. Now drought, on the other hand, is like this critter where you have a turtle that just kind of sneaks up on you slowly, but you don't want to let him bite you because when he gets a hold of your foot, he isn't going to let go. And so our challenge is to make folks aware of the true costs of drought, which will surprise you, and we'll get into those numbers here in a little bit. So one of the first images that might pop into your head when you think of drought, and if you just saw the Ken Burns series on public television this past fall, the Dirty 30s, the Dust Bowl years, these are the kind of pictures. Notice and pay attention in particular to the two pictures on the right. The cornfield on top and this dune of mobile dirt and dust on the bottom right. So that drifting soil that indeed led to the creation of the Soil Conservation Service as a result of the Dust Bowl years. But you might be surprised to know, and this photo looks very much the same way almost today in 2008 as it does now in 2013 for the Oklahoma Panhandle. This is what that looked like during the drought of the mid-2000s there in and around Cimarron County. This was the drought of 2002. You notice these, I don't know if my mouse is coming through to show this, but if you see that grain elevator, there's a couple of pretty good sized dunes of dirt that have drifted up against a fence row there that's kind of hard to see. But we have several other photos. If you go to the Drought Mitigation Center's website and just search for our photo gallery, you'll see a ton of photos from different states across the region. Some of those photos have been uplinked to us by folks in the CoCoRaHS network, in fact. So we showed those large dunes of dirt, blowing, eroding dirt. We also had that photo in the 1930s slide of the cornfield being impacted. This is actually a cornfield in Nebraska in the drought of 2002. And as you recall, the hydrological drought of the West that also impacted the big reservoirs with Powell and Meade in particular in 2002, reducing those reservoirs way down, was also affecting parts of the western high plains and the western corn belt. Here's a cornfield that was, first of all, stunted in growth, but also devastated by grasshoppers. And that's our director in my case. So we do a lot of drought chasing. It's dangerous work, but somebody's got to do it. So that's what we do. Livestock was also impacted a lot, has been. It's really been decimated over the last several years now. The drought of the fall of 2010 that lingered in and sort of apexed in 2011 in the southern plains, eastern New Mexico, parts of southeastern Colorado, southern Kansas, Oklahoma, Texas, was really devastated by the drought, particularly with regards to livestock. The pasture and rangelands have been desiccated. There's very little forage there. They got by 2011 because a lot of the forage that came from around here, Nebraska, the Dakotas, Montana, Wyoming, where we had seen a couple actually historically wet 5-year period leading up to 2012. A lot of that forage to help out their brethren down south was shipped off by truck and train, etc., to help those folks out. Little did they know that 2012 would advance the drought well north all the way to the border. And all the way across the entire corn and bean belt, and so forage now is in real demand. Herds have been culled off quite drastically, and you're going to see that in the grocery stores here this summer. We also have hydrological drought. We have the agricultural drought we just alluded to with the corn and the cattle. This is a large reservoir in western Nebraska on Lake McConaughey. You can see the watermark here. This lake was also drawn down some 40 feet. And you can see the exposed beaches and dunes that resulted of the drawdown of the reservoir. So we have hydrological drought that kicks in a little later than the agricultural drought impacts. This is the Platte River, almost entirely dry. There's a little ribbon of water. This is the infamous, mile-wide, inch-deep river. You can see it was pretty much totally dry the last couple of years. This is a Republican river, so both of those rivers are shared with between several states, and there just hasn't been a lot of water going down these channels here the last couple of years. Fire was the other one. Obviously, fires kicked off the first impacts. After the wet years, we had a lot of fuel. We had a lot of forested areas that were suspect to fire. That was sort of the first major impact we saw in 2012, particularly along the Front Range and mountainous west, which also then moved into earlier in the decade. We saw these same sorts of fires go across the hill country and brush country of Texas, Nebraska, Kansas. So these grassland fires have really been an issue the last several years after the wet period because there was a lot of fuel there that dried out. So this had a devastating effect on miles and miles of fence posts and also caught up and killed a lot of livestock in the process. So these photos are pretty impressive when you look at the devastation that came about. So how does drought sort of stack up and compare to other hazards? As far as billion-dollar disasters go, if you look at the far right column, on average, and that doesn't include the drought of 2012 and 2013 right now, droughts are right up there with hurricanes. Those two make up by far account for the most damage of any natural hazard. And so these numbers do bear that out. There just happen to be more hurricanes, which leads to an overall larger number. But again, if you concentrate on the per dollar per event, you can see where droughts and hurricanes are by far causing the most economic loss across the United States. And that's really true across the globe for that matter. So droughts behave a lot more differently. Like the zebra, it's something to everyone that's different. It's a non-episodic event. So if you don't have an event that comes down in an isolated area that sticks around for maybe a few minutes or a few hours, and then it's gone. Maybe a couple days in the case of certain events, large-scale flooding or a hurricane. But for the most part, they are single one-off events that come and go. Drought has the capacity to sneak up on you slowly, stick around for months, even years, cover millions of square miles, and affect millions of people. So even though we don't have, typically in our country, fortunately, we don't have loss of life associated with drought, nor do we have total structural devastation that you see with hurricanes and floods and tornadoes. We still do see some structural damage, so it's probably not true to say there's no structural damage. You do see foundations. It's been a big issue. It's been $1 billion impact this last year from Minnesota through the Great Plains down to Texas, as well as water main breaks. When that soil recedes away from the pipes, the pressure is gone from that, and those pipes tend to burst. So we have seen some infrastructure issues with drought, but by and large, it's mostly non-structural. It's much more than that. The absence of a universal definition I talked about up front, and so therefore that last bullet of mitigation intervention, so what do we do about it? And so hopefully we'll talk a little bit about what do we do about it. But because of that, and because of policymakers and decision makers oftentimes have to worry about what's in front of them at that time, or their time horizon for planning isn't thinking out beyond, especially on the political side, when they're not going to be in office, the progress on getting folks to invest in drought mitigation has been arduous and largely a hard sell. And this is, I think, illustrated well with this cartoon graphic that instead of the hydrological cycle, we've got the hydroillogical cycle. So when it's raining, as you can see over here with the guy in the umbrella in the boat, everyone's good. We can just not worry about it. We get into this apathetic stage. Even when the drought is first starting, there seems to be general either unawareness or denial. Even though we see some impact starting to emerge, the tree stump that could be a problem for this boat, maybe the fish are starting to be impacted. Only until we hit that tree stump, only until it impacts you, you don't really maybe seem to be too concerned about drought. And then, of course, once it hits, it's like, you know, Katie, bar the door and dial 911, and someone's got to bail me out. So the problem with this approach is it just is doomed to repeat itself. It's a very reactive approach that often is very uncoordinated, is cost inefficient, it's poorly targeted, and so what it does is it decreases self-reliance and increases your vulnerability to the hazard. And really you could apply this to a lot of hazards, but this I think is a nice way to summarize how drought works on the mindset of folks. Some other characteristics of drought. One, it's very much a natural hazard, but it's also very much a natural part of our climate. We know this from tree rings and lake sediments and ice cores, and we can go back and look at droughts using those sort of proxy data or tools and sort of recreate a past climate with tree rings in particular, and we see that droughts have been around, and droughts will continue to be around in a changing climate regardless of which way that would go. This, I think, shows the cyclical nature of droughts, up and down, up and down. In any one year, you would expect somewhere in the United States, given such a large country, around 12–14% of the country in drought. That would be a line that goes about like this. What we've seen, of course, that stands out right away to you, of course, are the 30s. Multiple years in that decade, 2 years in particular, peaked out at over 60%, and in fact, almost 80% coverage. I think it was 78% coverage in 1934. The 50s and the Southern Plains is their drought record, Texas, Oklahoma. You can see the U.S. just peaked here at just over 60%, and several other years in the mid-50s got up there well over 50%. And then if you fast forward, it was a relatively benign period, say from 1970. We had the big drought in 88, 89. We had the drought of the late 1990s into the early 2000s that I spoke about earlier that peaked in 2002 that got up close to 50% coverage. And then we go to 2012 where we did actually get up to be the third largest aerial coverage next to the 1930s droughts back here. So drought, but you can see there's times when it drops way down too. But you'll notice that there's never a year where there's absolutely no drought in the United States. So, as I mentioned, we have the impacts of drought. That's pretty much how you define droughts. We have economic, social, and environmental. A lot of times the environmental seems to be not emphasized, as does the social, particularly with regards to physical and mental health. This is a big issue with droughts. We're seeing this with the loss of farms and increased suicide rates. We've seen it with a lot of upper respiratory and allergies being attributed to blowing dust and hospital emergency room visits and other sort of doctor room visits have really gone up in those areas. We're experiencing the droughts for the last couple summers. The Centers for Disease Control is actually documenting this, and I don't think in the past, you know, they were really sort of tying this thing to drought, but it's really there. And of course, if you know and you've seen the series on the 30s, the black lung or the dust lung actually killed a lot of people because of that. So it is an issue. We've increased our ability to keep the soil on the ground, but we can't do that altogether, and it gets out there and really causes havoc for folks. The other thing is these impacts, as I mentioned, they don't just stick around for a couple hours or a day or two. They can linger on for months or years. So that's a real difference between drought and other hazards. And then I've just talked about the health issue, but other things that aggravate drought are things like the mass migration of folks over the last 20 years into the arid, semi-arid parts of the country are putting a real big strain on finite resource. And so even without drought, there's some vulnerability there, but even a drought that comes along that may not have to be a drought of the 30s or the 50s or 2002, it's really causing dire impacts and economic consequences because of that strain on that finite water resource. So I think the bottom line with this slide is that droughts are about you and how it impacts you. That's what's defining it. But really, being aware of where your water comes from. Are you doing your job to conserve that water, even when times are good, to allow that water to be there when times aren't so good? And who's sharing that water with you? Conflict resolution is a big thing in droughts. All the states have, most states have these water compacts between them that sort of become the law of the river. But you know, when we look at how we define drought, it always comes back to the local level and always comes back to impacts. If we had to put sort of a loose net definition on it, it would just simply be a deficiency of precipitation from some expected normal, even though we know there's really not truly a normal, that extends over a season or longer period of time. And we break this down into the short-term drought. You may not see many impacts initially, meteorological drought, so duration's a factor, until we start seeing the impacts and how it affects either the environment, people, the economic sectors. Once it starts impacting those activities, then we start moving into these types of droughts. Typically the first one you see is related to soil moisture being drawn down, and that's agricultural drought. The longer the drought goes, you might start to see drawdown of stream flow, reservoir levels, and groundwater. That's hydrological drought. And then we have socioeconomic drought of the nature that we're starting to see now, when it starts to impact you at the grocery store and the goods you're buying that are impacted by the hazard itself. So this simple equation is sort of how we define your risk to drought depending on where you are. There's the hazard itself. That's how often are you exposed to a particular drought. And we can do that through the climate record. We can kind of generate the statistics and the numbers to get an idea of your exposure. The tougher one is the vulnerability, and that's, again, those social factors, population dynamics, not just an increase of the number of people on the globe or in a particular region, but shifts of those peoples in those areas. Urbanization, changing of that landscape, more rapid runoff off of concrete surfaces versus a permeable surface. And so these sort of factors influence how you are vulnerable to the exposure. And you put those two together and you have risk. So the good thing is droughts typically are temporary, and I might be jumping ahead here a little bit, but obviously a more permanent arid feature, that's aridity. A temporary departure is drought. So let's say we do go to a drier climate regime in the desert Southwest in 50 years. Drought would be a departure from that new regime. It's a temporary departure from whatever that climate regime is at that time. So they're temporary in nature, whereas aridity is permanent. And as we saw in 2012, the really big kicker was heat. That's what exacerbated the impacts. That's what brought upon a rapid onset, or flash drought as I like to call it, that really came on and put a whooping on the environment around it. High nighttime minimums are tough on livestock and people. They're tough on crops. The system doesn't get a chance to recover. During the cooler nighttime temps, we saw a lot of high nighttime minimums, and we saw some pretty unprecedented triple-digit heat that we haven't seen since the 1930s, with 100-degree days jumping off the charts, and low relative humidity, which is an issue for fire and other things. So what can we learn from all these droughts and moving forward? Well, we have to do a good job of diligent early monitoring. That takes week-to-week monitoring. Believe it or not, I mean, we're using a lot of the data that you folks collect there with CoCoRaHS. When we make the weekly drought monitor map, I'm using that because it has data in some areas where I don't have it in other places. We're looking at the impacts that you submit to the reporter. We have a team of 3 people here at our center that read through all of those and try to categorize them, get them into the database, and then put them online. So it's an integrated process of looking at the entire hydrological system. What's happening in the atmosphere, what's happening in the soil, and what's happening with groundwater and surface water. So that integrated approach is critical. And what we're trying to do is depict that as a matter of intensity or severity, if you like. How long does the drought last, and how large of an area does it cover? These things make up what we call the magnitude of droughts. So when we were kicking around an idea of a way to get drought in front of people back in the mid-90s, we wanted to heighten visibility of drought as a natural hazard for policymakers, for decision makers. what we did was we borrowed from sort of the tornado Fujita scale, category 1, 2, 3, 4 with hurricanes, F1, 2, 3, 4 with tornadoes, etc. So we did the research on other literature and thought, well, this would be something that we think people can kind of grasp onto quickly. They don't have to learn some complex system with simple number scheme, 1 being a drought of the first stage and 4 being the worst. So 1, 2, 3, 4. Following that keep it simple, stupid philosophy. And it's really caught on as sort of the state-of-the-art system now in the U.S. It's on the Weather Channel almost every day if you watch the Weather Channel, or you've maybe seen it in your major local newspapers too. So the reason I picked this particular date of 2008 was also to dispel a notion that droughts are only a Western feature. And you can see here that droughts, if we were to go back and look at the archive, and we have all the maps for every week back to 1999, I wish we had them all the way back to 1900, but we weren't doing it back then. You can see there was a really major drought here that affected sort of the coastal Carolinas in the southeast, Georgia, Alabama, Tennessee. This drought was pretty significant, but we've seen several droughts actually in the southeast since we started all the way back in '99. In fact, it was a big drought in the northeast and the D.C. area that actually spurred the policymakers and decision makers to get behind this product. So it got so bad that in Lake Lanier, above Atlanta, that basically gets Atlanta all of its drinking water. It's sort of an enclosed, confined basin. They were literally down to counting the number of days, maybe not the number of flushes here that they're showing. That's not Nolan. Nolan's a little taller than that, but for those of you that know him. But this is the Georgia state climatologist depiction, measuring the number of flushes left in Lake Lanier. So it was really that bad, and I mean that would have been a huge catastrophe. They had not thought about that could ever happen to them, and still, in fact, some people still don't think it can. So we still have a lot of work to do to get drought in front of people. So we know it's a very complex issue. It's cross-cutting across all these economic sectors, all those impacts I spoke about earlier, and with more people and more usage of water, conflicts continue to rise because there's only so many straws you can put in the drink. And I've touched on this, so I won't spend a lot of time on this except to say that it's not just a U.S. issue. Most of the major hazards and what causes the most damage in other countries is due to drought. And in other countries you have the compounding issue of famine that comes into play if their food security or water security both are impacted due to drought. So I think you can see the billions of dollars being thrown at it a lot of times is only to fix sort of the symptoms, but not really the cause. So we know that what do we do to spend some money on the cause? We can't stop droughts from occurring. They're going to come. They're going to happen. But what we can do is reduce our risk to those droughts. We can take steps to lessen our vulnerability. So mitigation is a good investment in doing that. And many states have drought plans. That's really grown, and I'll show you something on that right now. Back in 1981, there were only 3 states. Now we have almost all states. We have all but 4 states that have drought plans, and we have several states that are actually developing in the orange color here what we call mitigation plans. They are doing things like vulnerability assessments, a complete inventory of their resources, how they've been impacted by droughts in the past, and then what can we do to offset those impacts in the future. The states in blue are developing, going through a revision process, and the green ones are more the first initial wave of plans that were more green, more response-oriented. So when you're in the drought, who's going to do what? So just sort of coordinating the response. So drought mitigation is supposed to happen before a drought. You don't want to be doing this when you're in the drought. That's crisis time. There is a place for a response component in the plan, but drought mitigation needs to happen before you're in a drought. It needs to be steps taken before the impacts and addressing those at-risk sectors that I talked about earlier. So that takes a real shift in thinking for folks. It's easy to expect you to do something about it when it's happening, but then the next flood comes along and they've forgotten about the drought that occurred to them last year. So I'd like to just cover a few of our tools and then move on to the forecast and the recap of 2012, and then we'll open it up for questions. Here's where we stand as of this. Unfortunately, this map has the wrong date on it. That is March 5th of 2013. This is the current drought map with the wrong date on it. But you can see we've seen the epicenter sort of migrate over into the high plains, the northern Great Plains. We still have some pretty significant drought, though, down in the southern plains as well as the southwest and parts of the Intermountain Basin. So that's where we stand as of today. So the drought monitor, I didn't speak a lot about how it was made or how we do it. That'd be a whole nother seminar maybe down the road. But just to let you know, that's a collaborative effort between the U.S. Department of Agriculture, the National Drought Mitigation Center, and NOAA, which is basically our Climate Prediction Center, our Climatic Data Center, and our Meteorology group. They work with us, as does the Western Regional Climate Center in Reno, Nevada. So it's not an index per se, but rather a hybrid. It combines several indicators, and what's really unique about it is when we work on the map, we send it out for review for over 350 folks on the ground in each of these states that provide data, they provide feedback to help us improve the accuracy, get the impacts, get that line on that map correct. So it's a combination of objective scientific indicators using a rigid percentile ranking system, but it also includes feedback from the ground. After all, the impacts need to match up with those indicators or indices, and these folks are our ground truth. They're our sanity check, if you will. But this has become really big for policy. I mean, the U.S. Farm Bill now, unfortunately, is expired, so we don't have a Farm Bill. But it uses a drought monitor to trigger policy, to trigger relief. It's also used by the Internal Revenue Service and the National Weather Service. And several state drought task force under governors use a drought monitor as part of their toolbox. Here's a little bit of a distribution. You can see almost every state here well represented in the various colors here across the United States. And I've touched on this, so I'll speed along here in the interest of time. So I want to spend just a couple slides on impact. What are we doing about collecting that information that you folks are collecting for us too through the CoCoRaHS interface? Well, we need these to establish a baseline. This had not been done in a systematic way in the past. There was virtually nil out there except what you could get out of the newspapers or maybe a government report or two on the shelf, but nothing comprehensive at the state or local level. So we wanted to develop a baseline moving forward to know how droughts impact us now, where we're vulnerable. We often refer to this as being the face of drought. And moving forward into a climate change realm where, looking back 30 years from now, how have we been impacted, changed over that time due to the changing climate. So again, that's reducing our vulnerability. If we can understand where we're being impacted, what steps can we take then to reduce that vulnerability? It's also ground truth for things like the drought monitor, but also the new sophisticated computer models for drought indices and indicators. That's needed. And we also need to look at the qualitative stuff through the National Phenology Network or Nature's Notebook, through what you folks are doing through CoCoRaHS. All of that information is very good. It doesn't have to have an exact dollar amount on it to have value. So we developed a database and a tool back in 2005 that's grown to over 17,000 reports, 16,000 impacts to do just that. So that archive's there, it's searchable, and it includes everything that we're collecting from the CoCoRaHS network. In fact, that was I think one of our best decisions was to work with Nolan and Henry and the whole CoCoRaHS team to bring in the observing network of CoCoRaHS into our database on drought. That just had not been done. We wanted to beef up the user reports. We were getting a lot of information out of newspapers, but this is taking it right from the source, from you folks. So I just want to give a shout out to you all. Appreciate that and keep it going. We hope the drought goes away, of course, but when it's in your backyard, please do help us out, because Congressional Research Service, governors, their staffers come and search our database to know how their constituents are being impacted. So it can be sort of a mouthpiece for you folks as well. This just shows how that CoCoRaHS has helped us. We've seen, on average, a minimum number of reports through the months here. You can see with the big spike, obviously last year in 2012, of over 500 of these per month almost here. So that's been, like I said, it's been just a tremendous asset in building up our database. So to summarize on the drought impacts, they're all local. As I mentioned, drought is local. How you define it's how it impacts you. So that's one of the things I hope you take away from this. It's one of the leading causes of economic loss, and therefore we need to collect it. And it has to be a part of any drought early warning system that we develop by state or by country. Some other things I won't go into today, just wanted to expose you to them. Come to the National Drought Mitigation Center website and check them out. We provide a series called Managing Risk on the Ranch, a series of webinars on that, and a lot of tools about what individual producers, farmers, ranchers, in this case ranchers, what are they doing as best practices to tackle drought. We also have a product here, the second one, called Drought Ready Communities, helping communities, which could be counties, it could be cities, it could be groups, what steps can they do to develop a drought plan at their level. And then, of course, the state effort, the basin effort through NIDIS, the National Integrated Drought Information System, does it on more of a basin region. The first pilot they developed, employing Nolan and group there at Colorado State, was the Upper Colorado. But we're doing them in the southeast, and we're doing them in California, starting to spin one up in the Upper Missouri, and have done one in the Southern Plains. So this has been a very useful exercise. And then just making you aware of another tool coming to bear here in the next month or so, about ready to launch it, is the Drought Risk Atlas. You can zoom in and look at any one of 3,000 stations across the U.S. and look at the drought climatology, look at the characteristics of things like how often am I exposed to this sort of a drought versus that one, how long do they typically last, are we seeing an increased trend of droughts, are they changing, are they becoming more intense but shorter lived, so how large of an area are they covering, where do they start or migrate to, so the evolution and decay of droughts. This database hopefully will start to help us solve that question. So a little bit about the drought to wrap up. Last year was the warmest year on record for the United States, breaking the record of 1998. Every state in the U.S. had above average annual temperatures. 19 had a record warm year, and 26 states were in the top 10, several of those in the top 5. On the dry side, again, it's a large country. It came in as the 15th driest, but of note, it's the driest year since 1988, so that's a 25-year period almost. We did peak out at 65% back in late September of 2012, which I mentioned was right up there for aerial coverage of droughts we've seen in the 30s and 50s. And it hasn't been just drought. We've seen an increased up-ramp and trend of extreme events, those of the billion-dollar variety. 2012 came in second to 1998, which by chance, again, was the record warmest year, the second now after last year. So we had 11 disasters come in at $1 billion or more. So the estimates range anywhere from 35 to 77 billion. Those numbers are still going up because all the data is not in. Indemnities on crops alone, that doesn't include livestock, are expected to be up around 20 billion. So that will break all the records using the crop insurance program, and that does not cover the non-insured folks either. Here's a pie chart of those impacts taken out of the Drought Impact Reporter database. You can see ag is a big slice of the pie, but also fire, water supply is becoming big now too, public health I talked about earlier, and the environment. So this is a nice way for us to track each drought and sort of how they behave, and we can do that by state, we can do these reports by county, or by country. So the drought, you can see it's moved around a little bit. In 2011 on the top left, it was confined to the southern tier states, Southern Plains, Gulf Coast region. And we saw signs of it migrating north up the Mississippi, Missouri valleys in the fall of 2011. Fast forward to late summer, August of 2012, the epicenter was really over here in the Mississippi Valley in the eastern part of the Corn Belt. Then we had Isaac come on board and move its way right up the Mississippi Valley, brought a lot of relief to this area, and the epicenter now is pushed back westward into the High Plains region here in late January of 2013. So this again is the current map of March of 2013, even though the date says 2012. You can see that epicenter still firmly entrenched here, even though it's been a little bit more active pattern lately, not enough to really put a huge dent in things yet. This map just shows that, haven't seen this in the 25 years I've been doing this, with every state up here is a red like this. These are all the warmest years on record in the dark red. And you see a lot of them that come in as the second or third or fourth driest, fourth warmest in this darker salmon color. And then these states here, record dry and record warm. Both Wyoming and Nebraska saw record dry and record warm. Several other states in the corn or bean belt came in there in the top 10, as well as the Central Plains, and Colorado and New Mexico as fourth and second driest on record statewide. And here's an illustration of that heat that caused that. This isn't a big number for Texas, but when you get up here into Kansas and Nebraska, you see a lot of these 30s. That's a third of the summer, if you think about it, June through August. A third of the time we were at above 100 degrees during the day. Put a lot of strain on the system, to say the least. What's it look like moving forward? There's still concerns. We had a very low snowpack year last year. Even though it had been a bumper crop the year before, water supply was in pretty good shape to buffer last year. Here's where we sit on the left as of early March of 2013. A lot of these basins running anywhere from 15 to 30% below normal. These are the basins that feed the Platte and feed the Missouri, feed the Arkansas. There's a lot of concern because now we don't have that security blanket of going into 2012 in better shape. We've gone through a bad 2012, and so our savings account is depleted. We're going to be living event to event much earlier if we don't see a huge spring rebound in very short order as the max snow season on the ground approaches here in the next month across the central and southern Rockies. This was the forecast as of February. The new one is about ready to come out. It's not going to look any better. We see all these oranges and reds projecting 50% or less stream flow for the summer months. So this is of real concern moving into the summer of 2013. The seasonal forecast paints not too good of a picture. Temperatures here on the left, precip on the right, focusing on the bottom to the March through May temperatures, a much greater likelihood of being above normal temperatures in the southern plains and western Gulf Coast region. But really the entire eastern half of the United States has a greater likelihood of being warmer than normal over the spring, early summer period, which isn't good coming off of a pretty dry fall and winter thus far. The dryness is expected to be entrenched out here in the west more so, and maybe a little bit of continued recovery here in the Great Lakes and the eastern Corn Belt. So that leads us to this forecast. The seasonal drought outlook shows all this area of red is persisting drought through the end of May of 2013. These areas in yellow expected to develop in through the end of May, with some improvement here again in the central and eastern Corn Belt, as well as a little bit here in the southeastern United States. But all in all, a pretty persistent picture of drought coming along with us in 2013. So all the models that generate estimates of sea surface temperature, and this is what drives sort of the climatic models that then determine those precip and temperature that we looked at, they're pretty much in agreement that they're keeping us neutral. So anywhere between a plus or a negative 0.5 is considered sort of neutralish. When we get up there above or below that, then we're either into an El Nino on the warm side up here, or we're down to a cooler sea surface temperature regime, or La Nina, which is what we had the previous two winters. This year we were neutral. Early on they thought we might go up into an El Nino. That might have changed sort of our atmospheric river, but it has not. And so it's really behaved much in persistence. It's behaved much like the La Nina winters of the past 2 years. Another way to visualize this is as you look in these 3-month periods, for example here February through April, March, April, May, June, notice the green here shows a pretty good likelihood, over 50% likelihood of neutral, persisting all the way into early next fall. So that's sort of where the models tend to be trending us. It starts to look pretty neutralish, which makes forecast skill pretty difficult for those guys and gals that are forecasting, because the models, you're not getting a lot of skill out of these forecasts with a neutral type of outlook like this. So to wrap that up, 2012-13 fall and winter hasn't been too good to us either. So we haven't had that soil moisture recharge we need. We need more snowpack out there to melt out. We haven't seen enough of that yet. Spring's going to be real critical for both soil moisture recharge, and I would add snowpack to this as well. We need some late season storms, which can happen. We've had some big ones recently in the Front Range and in the Rockies, but we don't like to rely on those, because when they don't happen, then we're in big trouble. So we just don't have that buffer, that little bit of savings account coming into 2013 like we did in 2012. So if we don't get the soil moisture recharge, we're more apt to see these heat waves continue. So to summarize and wrap up, obviously drought isn't just about the physical side of it. I hope you've seen that it's a lot about the impacts and the vulnerability. These things do not recognize geopolitical boundaries and borders. And I think the other thing that I'd like to emphasize are the need to collect the impacts due to drought. This is the voice to get this in front of policymakers and decision makers to invest in mitigation actions to do a better job of addressing drought. And then citizen science. I think we're really big here at our center, and I know CoCoRaHS is all about this. How can we tap into more social media? Can we geotag drought impacts and push those into the database more seamlessly? Take advantage of our youth that use this technology extensively, and let them know that what they're doing matters and that we are collecting that information and data, and it'll be there, more importantly, 40 years from now. That's what I'd like to get across to you all, and thank you all for participating with it, because at the end of the day, if there's no water, there's definitely no life. That's what it's about with drought, is water is essential. We're all to be stewards of that water moving forward. So here's my contact information that you can sure write down, and feel free to follow with me through email or phone. I'd be glad to help out, and then if we have any questions now through the chat, I'll be happy to try to address those as well. Thanks.
That's great. Thanks, Mark. I just want to let everybody know it's time for questions. So if you want to go ahead and type your question into the question box, feel free to please include your state and your first name, and we will be happy to answer your questions. So I think, Nolan, I'll give you the first question if you're ready.
Oh man, I have a whole bunch of questions. Mark, sorry, I tried to talk to you sooner and I forgot to turn on my mic. So
Okay.
First of all, I understand you had a little fun time with the media last year. How many interviews do you think you did related to drought with the media, either local, national, or international during 2012? And of those interviews, did any one stand out as being particularly memorable?
Oh, wow, great question. I know exactly how many I did. We document all of those. Myself and my colleague Brian Fuchs, who many of you have probably seen in the papers too, we did 762 interviews last year.
Oh, man.
So do the math on that per day. At the peak, we were doing 20 a day in July and August. 20 a day. Now that's not including the data requests. So between that and the data request, I think we had about 1,600 interviews and or data requests over the internet through emails. Now, as far as any of those that stood out, I think the interesting ones are the ones you get from Russia and Japan and China, and we get the international media calling in and say, can you come on Skype, and it's 9 o'clock and you're at home Skyping, and it's 2 a.m. in the morning in London, or we've done a lot of bizarre ones like that. So I think that's always the fun ones too, though, because people are watching and they know about the Drought Monitor, and that tool's done exactly what we wanted to do. I just never envisioned it would grow like that, just probably like you never envisioned CoCoRaHS would grow like wildfire either.
Yep, that's for sure. And before Zach starts reading off questions, I have another one. I have been encouraging the CoCoRaHS community to not only submit drought impact reports as impacts are emerging and getting worse, but also sending reports of improving conditions. Is that useful to you guys?
That's really useful on the Drought Monitor in particular. If we're on the fence, okay, we're sitting here at D3 in southeast Colorado, for example, and all of a sudden we start seeing these reports of, hey, these cool season grasses have really rebounded nicely, and then we're hearing other reports, maybe these stock ponds have rebounded a little bit, or this spring is now running at 90% of capacity. That can be enough to tip us from, okay, our drought indicator says it's like right on the cusp of D2 or D3. But when I read these sort of impacts from your group or just go into the database, that's enough to say, okay, I think it can improve one category. Let's improve this down. Let's make it better and go from D3 down to D2. So it is used. We do a summary every Friday and send it out to a group of people, a lot of those folks on the drought list, to say, here are the impacts we've had come in this week. Here's what we're hearing. And then the drought authors also chirp amongst themselves offline about impacts that we see coming in, both getting better or getting worse.
So in other words, it's fine to continue to encourage folks to report improvements as well as the opposite.
I think so, Nolan. And I think the other thing, I know there's burnout. How often should you do this? This thing goes on every week. I could send you a bad report, and I understand that, and that's okay. You don't need to do that. One thing I would like to encourage folks to do, however, is when it does get good again, we love those before and after pictures. What's it look like on this landscape when it's normal? What's it look like when it's really wet, or what's it look like when you're in drought? So feel free to share those with us. We don't share them with anybody unless you give consent. But I tell you what, those pictures worth 1,000 words. And when we talk to senators or governors and show them this picture that I've got up in front of you right now of western Oklahoma, they think that's the 1930s, and it's not.
Well put.
Alrighty, thanks Mark and Nolan. So let's go ahead and start a few questions. So I have one coming in from Gary from Minnesota. He's wondering, where is the water hiding during drought, since the world's water supply is never increasing or decreasing?
Yeah, good question. What happens is it gets redistributed. You're still recycling that same amount of water, right? It's just that it's being distributed in different parts of the world, unfortunately not in our part of the world right now in the midsection of the U.S. That's sort of, it depends on the atmospheric patterns it sets up that are based on lots of factors. Things like where are the oceans putting up a lot of moisture into the atmosphere, where's that jet stream, where's that dumping that rain. So even though we might not be getting it here right now, somebody else is getting dumped on, it's recycling that water back up in the atmosphere over there. And eventually when the patterns shift to a more favorable pattern for us, where high pressure doesn't block moisture coming out of the Gulf of Mexico, or doesn't impede a front coming across from the Pacific Northwest over the Rockies, once that pattern starts to change and it can tap into those moisture sources, then we break the drought. So, this is, again, a very current recycling type of approach of the hydrologic cycle, and droughts happen to be a normal part of that cycle.
Thanks. All right, so I have to ask, I've had a few questions about your title, I before E, so I guess some people didn't catch what's the story with that.
Well, it's I before E except after C. That's sort of a hard, fast general rule. What I was trying to say is that with droughts, and I should have done a better job of that now that I think back on it, I should have wrapped that up at the front better, that droughts don't behave like the hard, fast rules of other hazards. It's a different beast. It's the zebra. It's different to everybody. How do you tackle a hazard that means something different to every individual you talk with? So the old rule of I before E except after C doesn't apply to drought. It's a different hazard that requires different methods of both monitoring and planning and policy. That's what I should have said better. So thanks for calling me out on that, folks.
Alrighty, thanks for clearing that up. I have one from Phil in Florida, and I think we've all seen stuff on the news about the flurry of sinkholes in Florida.
Yeah.
So is the current drought having any impact on that?
Yeah, it does. What happens is when you draw down the water table, that's sort of the other side of if you could envision a balloon and there's water in the balloon and you take away the water, the balloon collapses. There's not that pressure force to keep that soil to support the weight above it. And if you have a heavy structure over an area that's got a weakness, and they have these limestone formations where if the water's not up right against her to keep the pressure against the soils above it, the water retreats, the soil can't handle the load above it, soils contract when they dry, the heat, that coupled with the weight of the foundation of a house, and it just gives way. And this is a perennial issue in Florida. They've had this happen a lot. Back in 2008, Currently, you're hearing a lot about it. People think there can't be droughts in the rainforest or tropical environments, and that's not true. Drought can happen anywhere across the globe in a year, including rainforest. So when we say drought's relative, if you're expecting 200 inches a year and you get 125, certain parts of the environment aren't going to respond well to that 75-inch deficit. If you live in the desert and you expect 8 inches of rain and you get 2 inches, certain things aren't going to bloom. It still puts a strain on the natural environment because it's used to a certain amount to get it through the year. So that's what we mean when we say it's all relative. But drought can occur in any environment, tropical or arid.
All right, thank you. We have a question coming in from Oregon. What are the time periods used for declaring what conditions an area is in for drought?
Well, that does depend on most of those declarations. Just to set this straight, are usually conducted at the state level. And then you have what we call secretarial designations. So for example, for drought, FEMA doesn't deal with drought because, again, we don't have the structural damage, the loss of life. You don't see a house floating through a dry cornfield. FEMA deals with those sort of disasters. The president would make a declaration for an area or a county. With drought, it goes through the governor's office. They have a drought task force typically that looks at a variety of indicators. One might be the drought monitor. Some states might not use that, but they're looking at other drought indices. They're looking at stream flow and groundwater and reservoirs and the condition of their crops or what have you, forest health, whatever. Maybe it's a fire issue. They declare a drought. That goes up to the Secretary of Agriculture. And to streamline that process, as a matter of fact, and as a matter of trivia, last year was a streamlining of any county that was D2 or worse. In fact, later on in the summer, they made it anything D1 or worse was automatically declared as a disaster by the Secretary of Agriculture. So it depends on if it's first of all, if it's a state or a secretarial level at the federal level. That's what determines the designation or a declaration. As far as what determines if it's ag or hydro, that depends on the triggers in a particular region or state. And they have a series of indicators that they look like. So Colorado is going to be looking at a set of indicators, including snowpack and others, whereas Georgia is going to be looking at different indicators based on their climatology in their region. But obviously the short-term ones are more of the agriculture, and then as the drought begins to last longer and longer and longer, when it starts to affect water supply, stream flow, reservoir levels, or groundwater, then it moves to the hydrological drought, which is denoted by the letter L on the drought monitor. The shorter term ag and environmental are designated with an S on the drought monitor map.
All righty, thank you. I have one from Nancy. In 2012, barge traffic on the Mississippi River decreased due to falling water levels. Do you expect the traffic to improve in 2013?
I think it will improve for the simple fact that the Mississippi Basin has really done much better this winter than the Missouri Basin. Now, having said that, the Missouri Basin, Nancy, as you probably know, is the largest basin in the country. The northern basin's pretty normal. It's better off than last year, but the central and southern basins, the past few storms have helped bring up some of the snowpack in those basins, but we're not anywhere near normal where we need to be to release enough water into the Missouri Basin that then feeds into the Mississippi Basin. So I think the upper Mississippi is better off, the Great Lakes region, although we do have Lake Michigan and Lake Huron are at record low levels, as a matter of fact, and the other Great Lakes are at near record low levels. But we have seen a better fall and winter precip regime in the Ohio and Mississippi valleys that will lead to better flows for the Mississippi part of the stem. The Missouri, on the other hand, which does again feed into the Mississippi, isn't doing quite as well. That's still of a little bit concern. So I'm not saying there'll be a full recovery, but it might be better enough to keep the barge traffic going. They've done a lot of dredging, so they take advantage of that. I should say not all impacts are negative. There's actually quite a few positive impacts that people take advantage of when you're in a drought.
All right, thanks. If you have time, I think we'll go for maybe about 5 more minutes of questions.
Yeah, that's fine. Sure.
So I'm sorry, I don't have a name or a state for this one, but how much of an impact will the big snowstorms of the winter of 2012 and 13 have on this widespread drought?
Yeah, a lot of times what you see is sort of localized improvement. The aspect or the catch in a particular basin is going to depend on the track of the storm. Are you on the windward or leeward side? And then how receptive was that basin for the storm in the first place? What are the reservoirs like on that particular stem that come off of those basins when they melt out later on? So that's all quite variable. I mean, if you look at that map I showed earlier that showed the basins and where they are at for sort of the amount of water in the snow that's up there, the size and the aspect of each of those varies pretty greatly. But there's no doubt that up until these past few storms, I mean, it was looking even worse than last year, which I hate to say, but droughts tend to come in multiple pairs or come in twos, if you will. That's not unexpected when you look at the long-term climatological record. We know droughts have lasted a lot longer than anything we've seen since the 30s, so we hope that doesn't happen again, but we have to be educated and be informed and know that it's certainly possible that a drought can go on 5 or 10 years. Having said that, it doesn't mean every year within that 10-year period will be a drought year, but that cumulative decrease of water supply in a basin begins to draw down reservoirs. You get less release then into the groundwater underneath and the aquifers underneath of these basins. So while I think there's been a little bit of recovery, the analogy I've been using lately is if I had a dry sponge, maybe the top fourth of that sponge, maybe the top third in certain basins is moist, but the bottom two-thirds or bottom half is bone dry, because we've tapped out a lot of our savings account during the hot, dry year of 2012. And what I thought was remarkable in 2012 was how fast water supply was depleted, and the temperatures did a lot of that, not just from the evaporation part of it, but also the transpiration from plants. The usage goes up when you have it really hot like that. That really sucked a lot of the water out of that sponge, and in just 1 year, the very large Lake McConaughey in western Nebraska went from near full capacity going into 2012 to just over half full, because they were doing full allocations. So now they have to really ramp that and put the reins on, because what if we don't get the snow in 2012, 13, and so far we haven't got enough snow to fully recover.
Great, thank you. All right, I think about one more question, maybe a couple more questions. One from Michael asking about evapotranspiration reports. That's a new thing that we're doing here with CoCoRaHS.
Yeah.
Would a larger database of these reports help you with establishing baselines and aid the predictability of drought conditions?
Absolutely. That's a critical, it's a huge gap. They took away a lot of our pan evaporation sites across the United States, which is one of the reasons I'm sure Nolan and the CoCoRaHS team was motivated to sort of get this grassroots collection out there. It can do a couple things. One, I think it will help us with the drought monitor. A lot of our traditional climate and drought indices don't take into account temperature. They take into account precip, but they don't take into account temperature. Now, some of them do, so we're developing new ones that do that. We're also using more satellite imagery, which can detect the health or stress of vegetation. They have a thermal band on these sensors, so they can actually detect the stress and the evapotranspiration rates. So we're using more of that to augment our on-site measurements. Now, the other reason that would be important to do what you're all doing with ET is that we can use that data as well to ground truth the remotely sensed satellite data. So if I have a large CoCoRaHS network of evapotranspiration values, that's a nice little proxy in a region to compare to what the satellite's showing. And then if I see a nice correlation, a nice matching up between the two, then I'm going to feel much more confident using that satellite imagery than I would if I didn't have any on-the-ground data. So we need both, but I think what you're trying to do with CoCoRaHS in that regard is essential.
Excellent, that's great. For all of you left on the call that are CoCoRaHS observers, you've probably heard about our evapotranspiration. If you're interested more in that, you can check that out on our website. Sorry, that's just my little plug.
Hey, that's okay. That's what we're here for. It is very essential, though. It's a great network, and I think it's important for you folks to know how we use that data.
Excellent, thank you. And the last question, I think, Nolan, do you have any more questions for Mark? And I think Nolan's still on mute.
Oh yeah, I was muted again. Sorry about that. I have questions, but if you have one last one, I'd be happy to use that one.
Okay, let me scan through here, and I thought I saw one more that popped up. I think it was back. Oh yeah, it was back to the aquifers. Approximately what percentage of water is stored in aquifers? I know this varies, but how long would it last after a season of above average or below average precipitation, for that matter? And this was from Paul in California.
Oh, that's a tough question. Yeah, it does really vary regionally dramatically. You know, for example, I'm in Nebraska. We sit over a huge reservoir called the High Plains Aquifer, the Ogallala. You might have heard it referred to. It's definitely a doozy, but it's really large. It's deep, saturated thickness. There's a lot of water down there. They do a lot of extensive metering and auditing and monitoring and restricting of water pulling out of that aquifer, but they're still pulling out more in a faster rate than Mother Nature can recharge it. The problem with mining groundwater in any basin or location is that infiltration and recharge is much, much slower through natural processes than compared to what we pull out to irrigate. So the more you rely on it, you're really taken away from the future water security, if you will, to pay for the present. So robbing Paul to pay Peter, whatever you want to call it. So it needs to be extensively monitored. I don't know exactly what percent is actually stored down there. One of the problems is we don't have a lot of real-time monitoring of groundwater across the U.S. USGS does a good job, but they have limited resources, and so these aquifers are perched, they're interconnected, they're not connected, it's a very complex subterranean picture. It's not like this big, huge bowl of an ocean underneath the ground. So it's all interconnected, and it looks like an ocean above the ground. It's just a much different environment down there, according to the geologists. So we don't have enough of that data, and in fact we're trying to do more and more of that to do a better job, because we do know though that the recharge rates just cannot keep up at all. And we've seen the High Plains and Ogallala really start to go dry in the southern plains, Texas, Oklahoma, Kansas. Now they're worried that it could dry up in the next 15 years. So we've got to do a better job, I think, of preserving that resource.
All right, thank you. And I do apologize if we didn't get to all the questions. We have a lot of questions coming in, but Mark did say he is happy to follow up with you later via email if we didn't get to your questions. So we will send him the questions that weren't asked, and he will try to get back to you sometime in the future. You're going to be out of the country for next week, so that might be kind of tough. But thank you so much for joining us, Mark, and taking time out of your busy schedule. We know that you're really busy, as you mentioned, with all of the drought stuff going on. Please join us for our next webinar next month on April 11th. It will be featuring Greg Carbon of NOAA's Storm Prediction Center in Norman, Oklahoma, and we'll be talking about tornadoes. And once again, please make sure as you leave to take our survey that pops up. Again, that helps us a lot with evaluations of these. And once again, thank you for joining us, and thank you again, Mark.
My pleasure. Thanks for having me on.
Yeah, thanks, Mark. Thanks a lot.
You bet.